Welcome to another GCBASIC demonstration. This is part 3 for the 18xxQ24 series. This is reading the ADC. So we're going to look at reading the ADC. So this is part of a suite of 20 videos I'm putting together. And this validates the Q24, but it's also an educational program. Like and subscribe. If you don't like and subscribe or watch it all the way through, the metrics by YouTube will not present this to users, so please like and subscribe. So, number 3, set the LEDs to represent the value of the ADC. So what we're going to do is we're going to configure the ADC, we're going to run a conversion, we're going to read the results, and we're going to put the results on of that potentiometer on the LEDs. Let's look at the LEDs just to make sure we know what we're doing. Got the camera set up. Oh, yeah, we've got a big screwdriver. I've got a potentiometer here, and we're going to set the LEDs to some value, but depending on what the pot is, okay, potentiometer. So it's a really good way of showing the expansion of the input outputs. So what I'm going to do, I'm going to connect up a potentiometer to RA0, and I've already done that. And it's a 10K potentiometer to RA0. So let me just bring my pen. This is our RA0 over here on the top. It's quite a useful port, and that's where I tend to do it. And basically, I've got the pot. There's three parts of the potentiometer. I've got the high line and the low line up to 5 volts, or my VDD. Mine happens to be 5 volts. And then I've got the middle of this connected to a small resistor and a capacitor down to ground to RA0. And that RA0 is the RA0 here on the left-hand side. Very simple. And our job here is to read the value of the position of that potentiometer. So what it was going to do, GCBASIC will do some initialization. It just does that in the background. We're going to create a variable to store the ADC results. It'll be a byte variable because it's only going to be between 0 and 255. Later on in the videos, we'll go to a much larger value. We're going to read the ADC, we're going to process it in a really easy way to get the results, and then we're going to get that value and we're going to set the LEDs and do it again, over and over again. In terms of a flow diagram, it looks like this. It's going to initialize. Let me bring up my little pen. We're going to initialize here, create a variable, read the ADC. And if it's less than 50, don't set any LEDs. If it's between 50 and 100, set one LED. 100 to 150, set 2 LEDs. Greater than that, basically set 3 LEDs. If not, set 4 LEDs. Do it again. Really simple. And the logic is just like that. It's really quite simple logic. So I'm assuming you've installed the software. You've got your programmer working, you've got your Q24 operational, you've got the 4 LEDs, and now you've connected a pot. With that, this is the diagram I've been using, and I've updated it to show I've got my ADC on here. I strongly recommend you use this type of diagram because you'll get confused. A.0 now has the ADC. And so what we're going to do is read the ADC to set the LEDs, use as a byte variable, and some really simple logic. So let's go into GC code, and I'm going to open up the list of demonstrations that are there by pressing Control B, or you can press this little icon at the top, or the Explorer. And I need to open up 40. Lots of files in here, so you can go Control F, and type in GCB, and there's a little filter, little triangle upside down there, filter, and it will only show you what you want. So here we go. Oh, I want 50050, show the AD value on the LEDs. That's what I want. Shut that window down by pressing Control B. And so this is the program we're going to walk through. Really quite simple. Set the chip to the 26Q24, very simple. And here I've updated the little diagram to show I've got my ADC on A0. I've got all these constants that were set before. And to be quite frank, you really should. If you really want to be good, you should really document out that you've actually got your potentiometer on there as well, so that you've got it documented. I'll leave that for now. And here's the main program. I've got two methods in here, but only going to look at one. I've got a do loop, and that do loop is it's a simple do loop. It's just doing it forever, and that's that big loop we saw before. And the do loop is that inside that do loop, just outside the do loop, sorry, we define a value, a byte value, which is ADC val. It's a byte. We can define bytes, and I'm calling a function called readAD, and readAD will return the value of a potentiometer connected to ANA0. We'll look at that in a moment. So that's the parameter I'm passing it, and it will put the results into here. So where did I get this from? ANA0. Well, I'll tell you where I got it from. This is called the data sheet. And in here, if I look through these diagrams and pages of it, if you look at the pin diagrams, it says here you've got something called RA0, and here's my diagram, RA0. That doesn't tell you the name of the analog port. It's in a table. It's always a table. And here it is. Here's the table. It says here, I'll zoom in. It's always in this type of table. It's not overly friendly, to be quite frank, but that's life. RA0, if you look at the AD column, it says ANA0. That's where I got it from. And each port has its own unique name. You need to pass that to the program. So in our source, you might want to, you should maybe document that part. So what we're going to do is once we've got that read, we're going to do our little test and say, if the value is less than 50, don't set any of the LEDs. If it's between two values, set one LED. Oh look, else if. If it's greater than 200, set all four. Wait for 100 milliseconds. So look what this is doing. Highly complex. readAD is setting up the analog digital converter for you, doing the conversion, and then setting up the variable for you so it can be returned. It simplifies the use. If I go into Zen mode and press the function key F5, if I can get on the right screen, you'll see it, compile it, it will program it, erase it, done. And now we have different LEDs, look, because as I rotate this potentiometer, 0, therefore the value must be less than 50, was it? I think it was 50. 50, 100, 150, greater than 200. And later on, we will see the values of these on a serial terminal to prove that it's doing it. And we're reading an 8-bit value. Very simple. In a couple of lines, we've done it. There's another method I've put inside of the source program that you can have a look at yourself. If I go back to the editor, I'll just minimize that one. And there's another way of doing it as well. Look, it's using a select case statement. You'll get the same results. I think the code might be the same size. It's compiled in a very similar manner. Now, I want to show you something. Also, what I did today, I went into my favorite smart engine called Copilot, and I asked Copilot to do exactly the same thing. I asked Copilot to generate me a program. Let me zoom in there for you. For a Q24, and it wrote this. I'm stunned. Set up the LEDs exactly the same as we have them documented, and then it says here's a do loop. Why don't I take a picture of that and we'll just annotate it in PowerPoint. Ooh, welcome to speech recognition. I'll just take a copy of that, put it in PowerPoint. I'm just going to stick it into my PowerPoint presentation for the time being so that you can see it. Doing it live. Not the way to do it, but that's live. Here we go. You can't quite see what I'm doing, but it will come back. back in a moment. Okay, good. Into PowerPoint. Go to the end of my presentation, and I've just added in. Oh, I've added in that lot. I'm so sorry. I've added in that little diagram. Great. So I've now got my pen, haven't I? I can use my pen. So what it's done here, here's the do loop, exactly the same do loop. What it's doing here is doing a read AD and putting it into ADC value. So that's the variable it defined here. That's great. It then scaled it. So it created another value and then it scaled the value from 0 to 255. So it scaled the 8-bit ADC value to a 4-bit value, and then it set the LEDs. It's just incredible. It's another way of doing it. You could play games with this thing. So what it's doing, it's saying I'll set the LEDs to the scaled value of the 4 bits that were remaining. Absolutely incredible. Fully documented. Now, there is an issue that says this is my search engine. It's learning from F and Venn, which I think it is, or it's learning extremely quickly. You may not get the same results, but I'm certainly getting fantastic results here, and hopefully those are being shared with the rest of you. But we'll see. Time will tell. Back into PowerPoint. Finish off the presentation. So what I want to do is we've just set the value of the ADC. That's what we've done so far. What we'll actually be doing is we'll actually be sequencing the LEDs in the next video to the value of the ADC. So we'll be sequencing the LEDs. At the moment, they're not sequencing. They've actually been represent the value. It's like a binary value. You have to look very carefully at the camera, which we really should do, I suppose, just to make sure you see the difference. This isn't really that clever. It's not clever. This is wrong part. It's a real kludge to do it this way. What we're going to do is we're going to sequence the LED. So 1, 2, 3, 4, 1, 2, 3, 4, and then we'll put some delays in it. Then we're going to put some interrupts in it. We're going to make it quite a sophisticated program. So with that, I'll go back to my PowerPoint and we'll call that a wrap. Enjoy.